Greetings, 6th grade parents and students. Mr. Korn here. Today's video is about equal ratios. What are equal ratios? How can we determine if two ratios are equal? And how can we test to see if two ratios are equal to each other? This is a follow-up video from last week's ratio video because this is the next step in our 6th grade ratio unit. So let's start with a question. Are these two ratios equal? A quick ratio review is that a ratio is a comparison of two quantities. In this case, the comparison of hearts to stars. We have 3 hearts and 2 stars, so therefore the ratio is 3 to 2. 3 hearts to 2 stars. What you see here is two different ways of writing a ratio. One way is to write the ratio with a colon in the middle. The other way is to write the ratio as a fraction, with the first number in our ratio going on the top of the fraction, and the second number of our ratio going on the bottom of the fraction. In our last video, we discussed that another way to write a ratio is with the word to, T-O, in between the comparison instead of this colon here. But for now, we're just going to use these two forms of the ratio. So we're looking at two ratios, 3 to 2, 3 hearts to 2 stars, and 15 to 10, 15 hearts to 10 stars. Are these ratios equal is our main question. Let us find out. What we have down here is something the 6th graders have been learning called a ratio table. This is simply a table that can be used to organize our numbers to see if ratios are equal to each other. And we can see the relationship between ratios. So we're looking at these two ratios, 3 to 2, 15 to 10, to see if they are equal ratios. Here's how we find out. First, start with the smaller of the two ratios, which is 3 to 2. And what we can do is we can put these ratios right in our table. Remember, our 3 talked about our number of hearts, whereas our 2 talked about our number of stars. So when we make a ratio table, we like to put labels in our ratio table to keep it organized as to which numbers represent which, quantities. So the top row will be our numbers for our hearts, whereas the bottom row will represent the numbers for our stars. And remember, the ratio we're starting with is the smaller of the two, which is the ratio of 3 hearts to 2 stars. So we simply write the number here, 3 in the hearts, which is the top row, and 2 for the stars, which is in the bottom row. So what we have to do is keep this ratio going. Right here I have 3 hearts and 2 stars. But what if I added 3 more hearts? What if I had 6 hearts here? How many stars will I need to have if I'm keeping the ratio the same? Well, remember, our starting ratio is 3 hearts to 2 stars. So what that means is that every set of 3 hearts needs to get 2 stars with it. So here you'll see we have 2 sets of 3 hearts. These 3 and this set of 3. This set of 3 hearts gets 2 stars because the ratio is 3 to 2. But then also this set of 3 hearts also gets 2 stars. So if you'll notice, when we have 6 hearts, a 3 and a 3, we have to give 2 stars for each set of 3 hearts. So when we have 6 hearts, we have a total of 4 stars. So what we can say is that the ratio here, 6 to 4, is a ratio that's equal to 3 to 2. So far, we can say that the ratio of 3 to 2 is equal to the ratio 6 to 4. Okay? So we can say that so far these two ratios are equal because we kept the comparison the same. Every time we added 3 hearts, we added 2 stars with it because of the 3 and the 2. One thing that you may notice is that if you look between this here, we actually have a multiply relationship. We have a times 2. What we did is we took everything here in this top box, 3 hearts, and we times it by 2. We took 3 times 2 gives us 6. So we must also share that same relationship down here. We take 2, multiply it by 2, and get 4. We basically doubled the amount of hearts and doubled the amount of stars. Okay? So that relationship is important to determining equal ratios. Okay? The other relationship that you may notice is that we just keep adding 3 every time, where down here we keep adding 2 stars every time. So let's do the next set. Okay? So suppose I had 6 hearts. Suppose I add 3 more hearts. Okay? If I add 3 more hearts, then down here I need to add 2 more stars. This set of 3 hearts needs to get 2 stars. This set of 3 hearts needs to get 2 stars. This set of 3 hearts needs to also get 2 stars. So that ratio of 3 to 2 stays in place. 3 hearts, 2 stars, 3 hearts, 2 stars, 3 hearts, 2 stars, giving us 9 hearts and 6 stars. And all we do is we keep the same relationship going, 3 to 2 every time, and we will keep making equal ratios. So this is the first step to determining if 2 ratios are equal. Let's add another set of 3 hearts, which means now we have 12 hearts. This set of 3 must get 2 stars. This set of 3 must get 2 stars. This set of 3 must get 2 stars. And this set of 3 must get 2 stars in order to keep the ratios equal. So, when we have 12 hearts, we have 2, 4, 6, 8 stars. Let's say I added 3 more in the next step. 3, 6, 9, 12, 15. Remember, each set of 3 hearts needs to get 2 stars. So we have 1, 2, 3, 4, 5 sets of 3 hearts here. So down here, we're going to need 5 sets. 1, 2, 3, 4, 5. Oh, that's hard to see. Sorry about that. 5. So when we have 15, 3, 6, 9, 12, 15, when we have 15 hearts, we have 10 stars. So if I complete the ratio table properly, adding 3 hearts and 2 stars each time, making sure that every set of 3 hearts gets 2 stars to go with it, eventually, after the 1, 2, 3, 4, the 5th try, I will have the ratio of 15 hearts to 10 stars. So therefore, I can say that yes, 3 to 2 and 15 to 10 are equal ratios. Because when I kept that 3 to 2 comparison going, eventually I got the ratio of 15 to 10, 15 hearts to 10 stars. So making a table of equal ratios is one way to determine if ratios are equal. All these ratios here are equal to each other. 3 to 2 is equal to the ratio of 6 to 4. which is also equal to the ratio of 9 to 6, which is also equal to the ratio of 12 to 8, which is also equal to the ratio of 15 to 10. Okay, let's look at another example. Again, are these ratios equal? This time I'm using a different ratio. I'm doing a 4 to 1, 4 hearts to 1 star. And I'm asking, is the 12 to 5 ratio equal to the 4 to 1 ratio? Are these two ratios equal? A 4 to 1 and a 12 to 5. Well, let's try. So, let's start with my smaller ratio, 4 to 1, and put that in our table. Remember, our labels go off to the side, and the 4 represents the amount of hearts, because it goes in the hearts row, and the 1 represents the amount of stars. So let's scale it up. Let's make equal ratios. So if I added another 4, remember, each 4 in the hearts gets 1 star. So since I have 2 sets of 4 here, I need to have 2 stars. So I can say my next ratio is 8 hearts to 2 stars. So far, 4 to 1 and 8 to 2 are equal ratios. Let's keep going. Let's say I add another set of 4. 4, 8, 12 stars. I'm sorry, 12 hearts. Remember, each set of 4 hearts in this ratio, because my ratio is 4 hearts to 1 star, so every set of 4 hearts needs to get 1 star. I have 3 sets of 4 hearts, so this set of 4 gets a star, the middle set gets a star, and the third set of 4 gets a star. So I can say I made another equal ratio, 12 to 3. And then I can keep going. I can add another set of 4 hearts. And this time, I can have 16 hearts. So if I have 16 hearts, that means I would have 4 stars, because each set of 4 hearts gets 1 star. So 1 star, 2 stars, 3 stars, 4 stars. 1, 2, 3, 4. So what I have here, again, is a list of equal ratios, because I'm keeping that 4 to 1 comparison the same. Every 4 hearts I add, I'm adding 1 star. So I can say that these ratios are all equal, 4 to 1, 8 to 2, 12 to 3, and 16 to 4. But my question asks, is the ratio 4 to 1 equal to the ratio 12 to 5? 12 hearts to 5 stars. Well, it's actually not. Because if I look at my table of equal ratios, I'll notice that when I have 12 hearts, I should have 3 stars, not 5. So that means that these two ratios, 4 to 1 and 12 to 5, are not equal ratios. Okay? Not equal. Okay? 4 to 1 would be equal to 12 to 3, not 12 to 5. Okay? Let's look at one more example, and I gotta look at a different type of comparison. Okay? How do you make How do you make equal ratios? Suppose I have this ratio 3 to 7. Okay? You can make an equal ratio, well, by filling out the table. So 3 to 7, if I just add another 3 here, I get 6. Then I just have to add another 7 down here. Every time I add a 3, I need to add a 7. So 6 to 14, 9 to 21, 12 to 28, and so on, would all be equal ratios to 3 to 7. So if I ask to make equal ratios, one thing you can do is set up an equal ratio table and just keep adding the ratios in order. Every time I add a 3, I got to add a 7. But there's another way you can do it too. You can use the multiplication relationship. So in order to make a ratio equal, all I have to do is multiply the top and the bottom number, both numbers in the ratio, by the same multiplier. And I can pick anything as long as I do the same multiplier to the top and the bottom. I can times them both by 4, and I'll make an equal ratio. If I multiply the top and bottom by 4, 3 times 4 gives me 12. 7 times 4 gives me 28. So I can say that 3 to 7 is the same or an equal ratio to 12 to 28 because I multiplied both numbers by the same amount. And look, 12 to 28 is actually here in our ratio table. Okay? And I could use actually any number to make an equal ratio. I can multiply them both by 5 if I want to. So let's see if I multiply them both by 5. Times 5 times 5. 3 times 5 is 15. 7 times 5 is 35. So I can say that 3 to 7 is the same as 15 to 35. They're both equal ratios because I multiplied both numbers by the same amount. And if you look down here, if I kept going in the same ratio, 3 to 7, I'll eventually get 15 to 35. So if I added 3 more here, it would be my 15. And if I added 7 more here, you guessed it, it would be 35. So let's use this multiplying trick to look back at our very first problem. Okay? Remember, my first problem is 3 to 2 and 15 to 10. Were they equal? So, is the ratio of 3 to 2 equal, is it equal to, I'm going to put a question mark there, 15 to 10. So sometimes I'm going to ask the student, are these equal? Here's one way you can test. You can think. Of course, you could make a ratio table like we just practiced, but you can shortcut by thinking. 3 times what gives you 15? Well, we know that 3 times 5 gives you 15. So, does 2 times 5 also give you 10? Yes, it does. 2 times 5 is 10. So both numbers in the ratio shared the same comparison. I multiplied 3 by 5 to get 15. I multiplied 2 by 5 to get 10, so therefore they are an equal ratio. But then let's look at our second problem. We looked at 4 hearts to 1 star and 12 hearts to 5. Was 4 to 1 equal to 12 to 5? And we determined through the ratio table that 4 to 1 was not equal to 12 to 5. But let's look at it this way. Is the ratio of 4 to 1 equal to the ratio of 12 to 5? Let's see. And I'm going to put a question mark because I don't know if it's equal. Well, we do, but we're going to figure it out. So first, 4 times what gives you 12? Well, I know that 4 times 3 gives me 12. So in order for these to be equal ratios, this times 3 must give you 5. If I take 1 times 3, does it give me 5? No, it does not. 1 times 3 is 3. So this relationship did not work out. 4 times 3 gave me 12, but 1 times 3 did not give me 5. So these are not equal ratios. Okay? Let me know if you have any questions. Sorry for the long video. You can watch this video in segments or rewatch it. And have a great day. Bye-bye.